Hi, welcome to today's episode of Control Intelligence. I'm Anna Townshend, Managing Editor of Control Design, and your host for today's podcast. In this episode, I'm joined by Jeff Johnson, Mechatronics Product Manager at Beckhoff Automation, and he'll be talking about some new technology. The XPlanar uses flying motion technology to improve performance. Let's learn more about how this differs from traditional designs and how it applies to many different applications.
Hi, Jeff. Thanks for joining me today.
Hi, Anna. Thanks for having me today.
Great. So let's get to it. We've got a pretty specific topic today we're going to talk about, which is the XPlanar. So this is Beckhoff's flying motion technology. So tell us, what exactly does that mean?
So XPlanar is based on the principle of magnetic levitation. So you think back to our first physics labs where we played with magnets. We had two magnets with the red and green ends. And, you put the red ends together, it repelled, and you put the green and red end together, and they would attract. So the XPlanar is based upon, the similar principles. Like trains, they've been around for a long time, and they have like two sets of magnets, one for lifting or floating the train and another one for pushing it. So with the XPlanar, we add a second dimension to that concept as we don't have any track to follow. So the movers move freely in the XY plane. Over what we have is tiles underneath. So we have tiles that generate a varying magnetic field, then that allows us to levitate the movers and then move in the XY plane or actually in 6 degrees of freedom. The tiles have like a flat array of coils, so thus the XPlanar name comes from the planar array of coils, and then we generate a varying magnetic field, and then that gives us the motion to propel and lift the movers.
Okay. So let's talk a little bit about some of what makes this technology unique. You mentioned the 6 degrees of freedom. Why don't you talk about what that is and sort of how this differs from traditional designs?
Okay. So we arrange the coils of magnets to give us the 6 degrees of motion. So we can move in X and Y direction up to 2 meters per second. We can float or levitate above the surface of the tile by 0 to 5 millimeters. You can also rotate the mover around the center of the mover. So we can rotate plus or minus 5 degrees while in motion, or in a stationary spot, we can actually spin 360 degrees. And then we can also tilt in XY. So now that gives us the multi-dimension for doing lots of different processes on the machine. So as we're talking to customers, we can actually redesign the machine and the process around those 6 degrees. We can do like a wobbling or swirling motion for mixing product. It also allows us complete freedom in the path. So now we can skip optional stations to get down to like a lot size of 1.
Okay. I'm curious about overall performance and compatibility. How does EtherCAT and PC-based technology factor into XPlanar performance, and how does it fit in an overall machine control platform?
So XPlanar uses our TwinCAT automation software running on our industrial or embedded PCs. And then TwinCAT communicates the tiles over EtherCAT-G. So this is the first product that we've released using EtherCAT-G. So it's a gigabit network versus the standard 100 megabit network. But you can also mix and match the EtherCAT network, so we can use our traditional I/O and servo motors alongside the XPlanar. We have one programming environment for one industrial I/O network, so there's no black boxes or customer proprietary networks in it. So all of your machine I/O, safety, and other servo and stepper access can run on EtherCAT networks alongside the XPlanar. We provide base software frameworks so customers can quickly get their system up and running. And we also take advantage of the multiple core processors. So with XPlanar, it does take more processing power than some of our traditional products, but with the multi-core processors that we have, it allows us to isolate cores specifically for the XPlanar task, which run at a 250 microsecond update. So between the high-speed I/O network and the high-speed multi-core processors, it allows us to do everything in one system versus having to have multiple systems talking asynchronously to each other.
Okay. This product obviously has a lot of applications, but we're also sort of curious about the limitations. Does XPlanar have limits in regards to track layout or the application or industry?
So the tiles themselves are 240 millimeters square, roughly a little bit over, like 10-inch squares, but they can be arranged in any format. So you can make like a rectangle, you could do lanes with offshoots, you could do L shapes, you can do ovals. So it's pretty much really however you want to connect the tiles together. Currently, we can do up to 100 tiles with 20 movers, or 60 tiles and up to 40 movers. We are working on some new features that will release by the end of the year that allow us to handle basically an infinite size system. We can have systems work together. We currently have 4 mover sizes. They're all square, so it's like 115 millimeter up to 235 millimeter, which would carry like a 4.2 kilogram payload. At the low end, the 115 millimeter carries a 0.4 kilogram payload, and then we also have a stainless mover that will carry up to 1 kilogram, and we're working on other mover designs. But you can take and link movers mechanically together or even via software to carry heavier payloads. We're continuing to add a lot of new features, so really I look at it as the only real limitation on the system is our imaginations, because it is a unique way to design your machine around all the benefits of it, including since we're levitating tiles, there's no moving parts to wear or break down, so it's typically maintenance free. It's easily adaptable to hygienic and clean room type applications, because there's no mechanical wear on any of the parts. We've been shipping starter kits for a little bit over 2 years now, and we officially released the product at the end of last year. And we're seeing lots of applications across all industries, basically, from assembly, packaging, lab automation, pharma, food, beverage, interlogistics, entertainment. The whole feature set fits well in all of those different industries.
Well, great. Thank you, Jeff. I think I definitely learned a lot today, and I hope our listeners do as well. Thanks so much for joining me today. We appreciate it.
Oh, you're welcome.
Thank you to our listeners for tuning into the Control Intelligence podcast, and thanks again to Jeff Johnson at Beckhoff Automation for his introduction to the XPlanar technology. If you enjoyed this episode of Control Intelligence, don't miss some of our older episodes and look for new podcasts in the future. You can find them all on our website at controldesign.com or download via Apple Podcast and Google Play.